With this paper and presentation, we are going to analyze a new decentralized system for fair token distribution and seamless user onboarding. Blockchain is a promising new technology that aims to bring a new way to distribute digital value, but with many problems yet to resolve. For instance, difficulties encountered by new users to acquire, possess, and protect their digital values. When we talk about digital value on blockchain, we typically refer to something that, on Ethereum, is identified as tokens. In order to better understand this concept, let's see two kinds of tokens implemented in Ethereum: fungible and non-fungible tokens. The former do not have intrinsic value and can be changed with one another like dollar bills. The latter, on the other hand, can be treated as collectibles, like stamps or valuable coins in a collection. Tokens are typically distributed in various ways. For example, ICO, where they are sold and paid with value tokens like Ethers. IEO, similar to the previous ones, but with a custodial entity like an exchange regulating the process. Simple agreement for future tokens, in which investors buy the promise of the token delivery, or airdrops, a proper giveaway of tokens among randomly selected addresses. Most of these mechanisms require the user to possess a wallet and, often, to pay the fees for the token redeems. One of the main solutions to these problems is represented by a custodial wallet. A trusted entity creates and holds the private keys for the users. In this way, the entity can act on behalf of the user, also paying fees in case. And the user is not responsible for the private key management. Obviously, the downside to this is that the user is not the real owner of the wallet. The burner wallet was created together with the XDAY project. It allows to create a wallet on the fly, to receive crypto on that wallet, and to transfer the value without the need to pay for transaction fees. The main drawback to this solution is that there are some points of centralization, among which the web server that provides the application that, in case of unavailability for some reasons, makes token collection impossible. Our work's goal is to realize a mechanism which is fully oriented toward the ease of access for the user. So it needs to have minimal entering friction. It also needs to enforce the decentralization and fairness. In other words, the user should not lose ownership of their belongings, and he should be able to verify the fairness of the random distribution of the tokens. The proposed architecture foresees the interaction of Ethereum blockchain, a decentralized file system, IPFS, and a server, which does not represent a single point of failure, as we will see. In particular, two smart contracts, two web applications, and an optional relay server are used. Technologies used for our prototype implementation are Solidity as a smart contract language deployed on Ethereum mainnet, modern JavaScript framework web application bundled in a single file, and IPFS as file system which holds the web application. For starters, a QR code is distributed, which contains the URL that points to a web application and a private key that represents the right to redeem a token. The Proxy web application is the first page that the user will land on and is only responsible for getting the latest available IPFS hash corresponding to the latest version of the token distribution web application. The hash corresponding to the latest version of the token distribution web application available is stored in the versioning contract so that the information about it is public, permanent, and traceable. The heart of the system is the web application, which allows to generate a wallet or to connect an existing one, and allows to sign a message with a private key inside the QR code, which allows to prove the right to redeem a token on the created wallet. On the other side, the distribution contract verifies the signature of a message, verifies that the related public key has not yet been used, eventually mints the token, and dynamically associates a digital asset to it. The relay server receives the signed message, not modifiable, and passes it to the smart contract. This process allows users which do not possess cryptocurrency to complete the transaction and ask for token redemption, making the relay server to pay for the fees. Note that without this server, the system would not be compromised, since everyone else, including the user, could pay for the fees, granting the transaction execution. We realized a prototype of the described system, and we used it during an event held by Politecnico di Milano. During the event were distributed physical tokens to all participants with a QR code printed on, which allowed a token redeem, linked to a PDF report of the event. We now report some of the main figures related to the case of study proposed. More than 100 tokens were redeemed within the first hour. A total of 370 tokens correctly distributed during the whole event, and a grand total of 881 transactions was generated, including the token mint process of the 500 initial tokens. The average cost of each transaction is about 27 cents of an euro. In conclusion, we can say that the proposed onboarding strategy has proven to be effective and simple, even for novices, in a real-world event at Politecnico di Milano. We can also say that this process do not add latencies or high costs. We are planning to extend our architecture to various kinds of tokens and distribution mechanisms. Thank you for your attention.